So remember that we learned that Java is a single inheritance language. And this means that you can only inherit from one class, from one superclass. But sometimes there may be situations where you need to inherit from multiple classes, so it makes sense to do so. So we can do this in Java, but we can use an interface, which is a different coding element, to inherit from multiple interfaces and also extend classes. And this is Java's solution to the multiple inheritance or lack thereof. So for example, here we have a printable interface, which has one method print. So the keyword is an interface that you use when you create an interface. All interfaces have methods that are by default public and abstract. So even though it doesn't say here public abstract, all methods of an interface will be public abstract. So you don't have to declare it as such because it's already declared as such by default. And so this is an abstract method, which means it does not have an implementation. It only has the method signature. And this means that the classes who implement the interface are going to need to implement the print as well. So what is the kind of situation where it would make sense to do this, and why would you do something like that? Well, if you work in a company where you have products, you have employees, you have customers, they all need to print. They won't be printing the same thing necessarily, but they all need to have a print method. And so by enforcing an implementation of the printable interface, and then, by this forcing them to implement the method, you ensure that there is a standard way of printing. So everybody is going to use the print method to print. How they implement it, it's encapsulated, but it's going to always be the same standard. It's not that in some part of the program of the company they're using print, in another part of the company they're using display, and then it just becomes less standardized. Okay, so if you wanted to implement an interface, you use the implement keyword. So in this case, the product class implements a printable interface. Interface names often will end on able, printable, serializable, and so on. So that's a convention, it's not a requirement. Another convention, you can start the interface name with I to indicate that it's an interface. Or you can just name it whatever you think it's appropriate. So the printable interface gets implemented by the product, and so the product then is going to need to implement the print method of the printable interface, which is print the description. And then you can use your interfaces that are implemented by the class as types. So this becomes polymorphic. So in this case here, you can have printable p is equal product.getProduct Java. You can use interchangeably the interface as a type. The interface is a type, and you can use it interchangeably between interface and class. Okay, as we have done here. And then we call p.print. You can consider when you might want to use abstract classes, when you might want to use interfaces. Something I didn't mention so far was that as of Java 8, there are some additions to the interface that make it more attractive to use an interface. So in other words, abstract classes have fewer advantages at this point. So as of Java 8, an interface can have what they call default methods. So it can have not only abstract, but also regular methods. They call them default methods. It can have static methods, also new with Java 8, and it does have abstract methods. So that's on par with abstract class. An interface can have static constants. An abstract class can have variables, static variables. So only static constants belong to the interface. It's interesting, I think the Android development studio is full of classes that rely on abstract classes, and I think Android uses Java 7 and earlier. They don't go up to the latest version of Java, probably for legal reasons. I'm not sure why. So I don't think they have access to these features, and that's why when you work with Android Studio, you're going to find yourself constantly inheriting abstract classes and then having to implement methods to perform certain Android building tasks. Right? All right, so the advantages of an abstract class, you can have instance variables, constants, static variables, and you can define regular methods as well as abstract methods, but now this is also true for interfaces. And the abstract class can have static methods, whereas prior to Java 8, interfaces could not. And the biggest, I don't know if the biggest, but the advantage of the interface that the abstract class definitely does not have is that you can inherit more, you can implement multiple interfaces. So you can implement printable, billable, and so on and so forth. And this makes it like a multiple inheritance. Okay. And so this is a reminder of what the two would look like, contrast and compare. And again, is this method abstract? Yes, by default, even though it doesn't say, an interface method is public abstract, is declared as such. So it becomes the same as here. So the syntax for declaring an interface is going to be the interface name. You can have your constant names here. So these are static constants and abstract methods. For example, the printable interface, and also you can have multiple methods, as in the second example. The product writer would have add, delete, and update. So this might be, and maybe if you add a read, it might be some kind of interface to what? Create, read, update, delete. Does it sound like something else?
SQL.
It sounds like SQL. So it could be an object mapping to a database. This is actually commonly done. Okay. All right, and here is an interface with 3 static constants. So we're going to work with this example momentarily. But for example, when you have different rows in the department, one way you could do it is to create 3 static constants and then assign them the value. So your company has admin, editorial, and marketing. There's actually a better way to do this with enumerations, but we'll talk about it in chapter 13. And this is an example of what we call a tagging interface. That's an interface that, as you can see, it has no methods. So what is the point of having a tagging interface? Can you think of any reasons why you might use something like that? So as the name tagging interface suggests, you're going to be tagging different classes with those interfaces to say, so this, you're indicating to the program or the programmers that, so for example, my class is serializable. What that means is it's suitable for being serialized. Serializable is an interface from the Java API, and it has to do with transporting data packets across the network. So you serialize them, and then they get transported to the other side, and then you unpack them. So a tag would indicate these classes support serialization, right? And that's what the tagging interface would be used for, and are used for. So here is the syntax. If you have a class that implements a couple interfaces, this is what it would look like. Printable, comma, department constants, right? And you can mix and match your custom interfaces with the ones from the Java API. And now your print method might look something like that. You're going to just print out different types of rows based on the static constants in the class. And this is the syntax for extending a product and then implementing an interface at the same time. So this shows how you can, again, an interface is a type, so you can pass a printable argument to a method, as in the example here. And then when you're calling it, you pass the actual values here. And so you can also pass an object, and as you can see, now you can call the start. This is how you'd call the static constants that we defined. If you want to use them, they call it a dot notation. Right? An interface may inherit from other interfaces, so the syntax for this situation is public interface, product, DAO extends those three interfaces. So an interface extends other interfaces, a class extends a class, but implements other interfaces. Okay? And so you can have a default method is the default particularly intuitive way. What the default word means is that this is a normal method. It's not an abstract, it's a normal method, so they call it default. And so you can now have a printable interface with a default void print, and that's a regular method for and to have an implementation. So that's pretty much what I wanted to tell you about interfaces. And I think I would like us to do an example, hands-on. Next. So let's start Eclipse. So we need to have a starter code here. So go ahead and bring up your flash drives and go.
Yes. Yes.
Put my flash drives in there.
I think I haven't started the FID. This is an old one. It used to be my passport for my Mac that I reformatted and then spray painted because I didn't like it clear, and I always forget my drives everywhere.
So exercise starts chapter 12 EX1 displayable text is what we'll be working with. Yes, we're going to do starts and then complete it ourselves.
I'm just going to do this. I'm pretty sure that's just it. If that's not the ones I have, then we're both SOL.
Chapter 12 EX1.
I've watched flash drives before and they still work.
All right, let's take a look. Note that this code includes the interface name displayable that contains a single method named getDisplayText that returns a string. So let's take a look. So it's in the test folder, and sure enough, here it is. We have a public interface displayable and contains a, so this is a public abstract method that returns a string. Open the displayable test app, then note that it includes a method named display that accepts a displayable object as an argument. So let's take a look here. All right, so it takes a displayable interface as an argument. Add an interface named department constants that contains the three constants admin, editorial, and marketing. So how do we add an interface? Similar to classes. So we're going to click on the package, new, and then instead of a class, you're going to click on interface, right? So interface is going to generate, we're going to give it the name department constants. Okay. And then the interface department constants is going to have three constants of type int. Admin is going to be 1. Editorial is going to be 2. And again, they're constants, so they're all cap case. All right. Step 5, implement the interfaces. Open the product class, then edit it so it implements the displayable interface. To do that, add the getDisplay method that returns the description of the product. So we're going to have a public class product, implement, displayable, and now it's going to complain because we need to implement the abstract method. So let's override public string, I believe it was, get display text, and it's going to return get description. And now the error goes away because we implemented the method of the displayable interface, right? So this is the method we added.
For some reason, I'm telling the board
So maybe did you misspell it? Are you sure it's spelled correctly? Make sure that this method is spelled exactly the same as the method here. You want to take a look? Papa? Okay. All right. So we added the implementation here to the product, and then the next step. Open the employee class, then edit it so it implements the department constants and displayable interfaces. All right, so moving on to employee. So this one is going to implement both the displayable and the department constants. You need to add the getDisplayText method that uses the constants in the department constants interface to include the department name and the employee number in the string that it returns. So here it's complaining about, for example, a typo here. So now does it make sense why one error went away, the other one is still there? What do we need to do next?
Displayable is spelled wrong too recently.
Okay, but we still have an error here related to displayable. But thank you, yes, that was a problem. So essentially it's the same thing now. You just need to get in the habit of implementing the abstract classes. So we're going to need to implement, or override rather, public string get display text.
Did you delete it? My example, it comes for
It has what?
it has override. That's what you're doing. I already have it.
You already have it, so you probably opened the solution, so I guess you just follow along.
Oh, okay.
All right? And so then we're going to have a string text that we're going to set to an empty string, and then text is going to equal to first name plus last name. And then another string department. And then we're going to do if department equals admin. Tutorial. Notice here we are able to use the static constants because we implemented the department constants interface, right? Department will equal to editorial. Else if and then text what's equal. Okay, so this should do it. Test it out. Java. Wait, this is the wrong program. We have to also modify the get displayable test app next. So I'll give you a moment and I'll type fast to finish here the implementation for this method. And you can see that we are comparing an instance variable in the product in the employee object with the int constant from the interface.
So if my admin editorial and marketing variables are highlighted in red, am I supposed to import them?
These are highlighted in red? Yeah, so it sounds like you didn't. Yes, so they come, where do they come from? Well, they come from here. They come from the, hey, from the public interface. So you need to then, to use it, you're going to implement the interface, right? So take a look there, make sure you're implementing it. If not, I can come and take a look. Okay, so did I. Picked a couple
Make it
today.
italic.
How did I make it italic? It should be everything else. I don't think the problem is of making it italic. I think the problem is different. So,
Follow the solution of it. That's good.
so do you see it here? This is underlined.
Yeah.
So that's where the problem needs to be addressed, right? And more specifically, you don't have the department constants interface. So you're missing. Take a look up here, please. All right. So you're missing this file. So I added the department constants.
You add in there.
You need to add it as a new interface, and you don't have that.
Create a class line.
It's not a class, so take a look again. So it's an interface, not a class. It's created in the same way from right-clicking, but then you don't create a class, you create an interface.
Okay.
So take a look again, please. Piano.
Let's right click on drag.
Right.
Yeah, right click. Save page. Interface.
Yeah, okay, got it. So default, the name.
Displayable department constants.
So I have this folder.
All right, and so then we are on step 7 of the exercise,
Parent folder that. What did I do?
which is to use the classes that implement the interfaces. Open the displayable test app, then modify the variable that stores the employee object so that it is of displayable type. So let's take a look here. Modify the variable that stores the employee object so it's of displayable type. I think it's up here. Let's see. So because employee, take a look at this, please. Because employee implements displayable type, we can change employee type here to displayable. And then the two types seamlessly can be cast into each other. So change the employee to displayable. Then add a code that passes the displayable object to the static display method that is coded at the end of the class. So we have a display method here, and it already, at least for me, it's taking a displayable object, D. So make sure that it's getting a displayable object, and then run the application to make sure that it displays the employee information. And so after you pass it the displayable object, then you can call the getDisplayText method on this object. So let's try this here. So welcome to displayable. Oh wait, let's see, we need to call this method. So right now we created the display method, but we haven't actually called it from the main, right? So this is the main. This also shows you if you wanted to have additional methods in a class that contains the main, that's fine. You just make sure that you put them after the main. In other words, we open the main here, we close it here, and then any additional methods have to go after the closing bracket of the main. So right now we have created the display method there, but we haven't called it. And we need to call it. So after we created our employee, we're going to say display. So in this case, we can call it with a employee, and we can also say display with P. So we can call it with a product object, then it will work because they both implement the interface and they're interchangeable. So if I do control, if I run the code, as you can see down here, I have John Smith, editorial, and Murex Java programming. So it's printing one each from the employee and from the product. And what you can do is change. So the values for the employee object and the product object are getting passed through the custom constructor, and you can change it here to verify it still works. So we can make John Smith be 1, which was admin, and we're going to make it Adam Smith. Sure.
So this is just showing us that we can use any super class or any interface instead of saying it was an employee. It's the same thing, right?
Right, you can use the interface. If the class implements the interface, you can use the interface as a type.
Okay.
Right. And see, take a look here. I need to figure out why there is a missing space somewhere, but other than this, You can see that I changed it. The employee object now is getting an admin value of 1. I think 1 was admin. And then the name is changed, so it's showing the new name here, administration, and then more Java programming. Oh, it's not printing the price, but actually it's not meant to print the price at this point. And you can add those details through the implementation. Jill?
So we didn't have to change employee to displayable, right?
No, you don't have to. I think it would work if you leave it as employee as well, but we're showing that you can. Right. And also showing though the display method you can pass, because it's of type displayable, you can pass when you call it employee or product. So any class that implemented displayable, you could pass as an argument to the display. So this is a little example of working with interfaces. I will not do the default method this time. Let's make sure this code works for you all. And if you have any other questions, let me know. Did it work? Great. So this is a pretty nice way of structuring. Welcome back.
Thank you.
Structuring the program. If you don't have any questions, it's time for our first break. And then we'll move on to chapter 13.
I'm going to need to rewatch that video.
Okay. You were busy looking at cats, weren't you?
No, I actually,
No,
we were both having problem building up the source code.
Yeah.
I got it.
Not responding, not responding, not responding,
Oh.
not responding.
Well,
Oh,
you
and
could
I-
have told me to wait for you. If it's a legit reason, I'll wait a little bit.
I had a dumber reason. I was looking at the source code for the wrong textbook.
No, that didn't make sense at all.
Yeah, I was like, why? But yeah, no. But I mean, you have the videos, so I can work this on my own time, and I work better by myself anyway. So
Right. And you also know that you always have the solutions, right?
Yes.
If you just look at the solution, you will not learn anything probably, but you do have them to fall back upon if necessary.
do they give this step by step for the examples?
They just give you the source code for the solution.
Uh-huh.
So you have to sort of know.
So if you have both of them open next to each other.
Yeah, that would
that's
be
what I'm
good.
gonna get past.
And then does the teacher's book like give you a, or do you before class go through and create like a run through like the way you just did the presentation?
I have the presentation given.
Okay.
I didn't do it all in one class, just see how you push through that. It all worked except for the very end. She asked. That's what's throwing up. She asked. For some reason, they go for all the other examples we've already done, just very straight into. Yeah.
And about book price game license. My question is, I just
So it doesn't go all the way back to the top. So move the, do you want to shop out of?
Because I have a client ask me,
You may need to put on updates. They just need to update the thing. And hopefully,
hopefully next year, I'm not sure.
yeah, because I don't,
Yeah. Because I have a client that, in now the West
Yeah.
yeah, they really can do like.
Should I can't see what's I lost her.
So you're still.
You're a Russian spy. Tell me what's wrong with Donald Trump.
So it's returning, you know, like to the top.
Yeah, I kind of confused. Actually, I sent some all. Yeah.
Oh, he opened me up
I know.
No, I saw that. Did you know we're bragging about your cooking.
Oh, I see. Just get rid of both. Like, so just use one. So just have like one.
Oh, that's your work.
Does that make sense? And so if they ask you when you want to that way I'll make sure you're.
Oh, yeah.
So you're gonna want to wait
Oh, I thought that was you.
Yeah, so where are you?
It's kind of what you do, right? It's what.
I have a brand website that she asked me to do, but she did not teach me, ask me to do, ask me to teach her to do.
So, because the answer never changes, the answer is always yes once you enter. It's never gonna go back up. It's never going to start at the beginning of the
Learn how to progress. You only ask me some questions,
Are you trying to fix her changes now?
no, she,
Oh, she just decided she could do it.
no, she cannot decide, she asked me,
Yeah. Or just, you know, or just like, the thing I like to know is
attach you to the project and decide her website, right? And she asked me to talk about it. I don't know the answer.
see what I do with
Kind of asked me questions how to create. Kind of stuff for me, and I'm serious, I really, you asked me to try on teaching you how to do it. Because I can do it, what you say here. You think you're very far away from.
So then it doesn't get set here from the very bottom.
And I assisted what's your project? Be honest, because you're gonna plan.
So somewhere along the line that's broken here.
Spend a lot of money.
You know, I suspect it's because you're using.
So I say, we know how much it costs to style her, that kind of down. I can tell you,
Yeah.
when you touch can, I would be like a year. But I can't say that.
But that was you.
Yeah, I have to.
That's just added this to the top. Right. Nice. Yeah, see that from your
Yeah, I wouldn't give him that look for free.
Well,
It's really for experience, sure, but
yeah,
now you know what you're doing, so you should be charging.
well, for
If you know what you're doing. I don't know. Maybe you don't.
I know what I'm doing is I got Ben.
Yeah, exactly.
Ben, she evaluated.
Yeah.
So what I need, I definitely plan this week.
Yeah.
I don't really have to new project. You take my investment. Probably, and then
Well, she doesn't seem like,
I mean, I would.
it doesn't sound like she wants you to actually
yeah, but
do the project. It sounds like
When you make
she wants
space,
you to
the-
teach her.
no,
well, I'm not a teacher, I'm not a
I just
teacher.
don't.
Exactly, that's what I'm saying. Yeah.
You know,
She can go take a class.
yeah. Definitely,
Or pay you. That's what
I
it's
prefer,
value.
that's respect.
And honestly, if I were you, I would just get rid of this whole
I
thing.
have to really because who do it, actually do it.
Option when you like to shop.
It's gonna start the conversation. So next time somebody asks you for the office, just clear.
Yeah, make
Because
sure
she
you know
say,
what they're
I'm gonna
asking.
go to the office and I thought you're gonna give me the account and then I get, you know, I told you I'm the web developer, you know what I'm doing.
Because
I just copy.
She gives us that as like focus class because I can kind of visualize you, but it's like you need to take two classes. Like what? So that's why I'm gonna take the first half out. Yeah, do all of that. Like get to work. Yeah, and then have the individual parts. And then reallocate it to the.
All right, so
Yeah, the shopping part.
back to, not back to, but forward rather.
Yeah.
Okay, who is ready to continue with chapter 12, 13? Now that we're done with chapter 12, are we good? Yeah, thank you for being participatory. I appreciate that.
I'll go to 13.
Every time you raise your hand, I'll give you extra 5 points.
5 points right now. I'll use 2 hands then.
All right, but now seriously, so we are wrapping up chapter 12, and I'm going to give you the quiz for chapter 12 next time, and now let's move on to chapter 13. And so the good news is that with chapter 13, wasn't planning to cover the entire chapter anyways, just parts of it, so I will show you. Let's see here. Screen share stop. So chapter 13. So the chapter covers inner classes, anonymous classes, enumerations, and documentation. And I will not go into inner classes or anonymous classes in this class. When we do the Android programming, excuse me, sorry. When we do the Android programming, those of you who are planning to do it, I'll talk about inner classes and anonymous classes because they're used in this context. It turns out you use inner classes a lot when you do GUI programming. So I'm skipping over this for now. But I'd like to talk about enumerations and how to generate documentation with the Java doc utility. So why is this not working now? Let's see. I wish I had an app that would actually calculate how much percentage of my time or your time is spent, in fact, waiting for technology to do something so that you can do your work. I think it's like probably 20% of my time waiting around.
Your app would have to load fast.
Yeah, right. So that would be some, maybe we should develop an app like that. So this is the GUI using Swing, by the way, for Java. And if we have time, we're going to play with it later. It's just not really, I don't think, the most essential skill at this point. And so the GUI example allows you to look at the anonymous and classes. So I'm skipping over that. Don't worry about it for now, unless you want to. And I skipped it in the other class too, by the way. And so let's talk about an enumeration. So remember in the chapter 12, when we wanted to create the department types, employee types, we used the constants with int. And that was okay, but how about a different approach? Java offers the enumeration or the enum constant type. And the enum constant type is a special type where you can define within the type only the constants that you need. So in this case, if you have an enumeration for shipping, then you can say, I have, what type of shipping do I have? I don't have any possible type. It's not like anything goes, but I also don't have just one. I have, in this case, I have 3 different types. So this is a good candidate to put into an enumeration. You create an enum again by right-clicking and adding the same places you add classes and interfaces. And so shipping type, next day, second day, and ground, for example. How do you use it? So you can have a shipping type, it's a type again. Second day is going to equal to shipping type. And then when you say dot, it's going to present you the option of the values of the enumeration constants. Okay? So far, so good? How do you use an enumeration? You can pass it as an argument. So you're going to pass a shipping type to this method. So this is an enum. And then based on the different types of the shipping, if it's next day or second day or however, the prices are going to be set to different values. This is one way how you'd use enumeration. And then you return the shipping amount, which is a double. So depending on the type of enum that we passed in, this will go out with different values. Right? One day is $10 and so on, $10.99. And then, so this is the method declaration. So when you call the method, you're going to say get shipping amount, and then you pass it as such. You pass it as shipping type dot. In this case, let's say you want to ship second day shipment, pass it like that, and this would work. So this is good. The enumerations are implemented as ordinal values starting with 0, so it's going to be 0, 1, 2. But you can't use it as ordinal values directly. So even though it's 0, 1, and 2 indexed, you cannot just say 1. You actually need to say the name of the constant. Okay? However, you can get the name and the ordinal of the enumeration. So the ordinal is going to give you the number value. So if you get the ordinal of second day, it will be 1, because we have 0, 1, and 2 in this case. The name will give you the name. So you may want to add a method as part of the enumeration. And in this case, by overriding to string from the object class, you can use the ordinals here. So the ordinal is 0, it's 1 day shipping, and so on. There's just an alternative to using the constants. It allows you to see how you might use the ordinal method that's part of the enumeration implementation. And then you return the string. Right? Any questions? You can also call. You can use enums as static imports, which means you don't have to say shipping type dot. You can just say UPS ground. but this is more confusing, so it's encouraged as a better practice to actually spell out the name of the enum dot the constant, right? But this is a valid syntax. It will not give you a syntax error. So the next topic for tonight is the Java doc, but before we do this, I have an example creating a card suite that is going to allow us to use an enumeration. So let's do that. And then if we don't have time, we're going to do a Java doc on Monday, and that's okay. All right. So more coding. Let's go ahead and start Eclipse again, if you can.
Wow, look at that.
You know, it's
Infinity.
one of the instructors was, sorry, it's an infinity. It's an example of a recursive function as well. It's awesome. So here we go. So we're going to have a new project. Yes, I have a feeling that this will be the last exercise for now, for today, and then we continue with.
What do you call it?
This is going to be faster, so just 1 second here. So this is not from the book, but it's posted under the coding examples in chapter 9, or week 9. Just a second here. So you're going to call it card suite tester project.
So we're going to create a new project, right?
Yes, please.
Oh, that's a hard drive. It's from a hard drive. It's got a disk in it.
You can see? What can't you see?
The project name, please.
So this was
Card suite tester?
See, yes, they are.
Okay, so,
They're from Max. I formatted it.
all right, guys, if you don't want to do
Sorry,
the code, at least don't
I'm paying attention. I'm shutting up.
distract others. Are you still not able to get in your Eclipse? Okay, so now then you should be adding a new enum, all right? So right click, new enum, and this one is going to be called suite. For a suite of cards,
Package.
suite. In the same package, we only have one package, so in the same package.
What's the new enum again? Suit.
Suite. As in spades, clubs, hearts, and diamonds.
Is it the convention that they're all capitalized?
Yes, so the enum is the constants,
Because they're constants.
and they'll be capitalized, correct. So we have our enum now. We're using an enum for the first time, and you can see that it makes sense to use it for something that has only 4 possible values, right? And then we're just working in the same package. Then we're going to add a class named card. So we're going to add a class to represent a playing card,
It's a new class.
Another num.
a new class, not an enum, I said a class, right? So public class card,
And no main.
not in this one. If you want to set up the project, then go ahead right now and add another one, new class, and you can title it main, and you can select here the main You've been up until 4 a.m. or something? All right. So let's go back to the card class and let's model a card object. So it's going to have instance variables. A private suit, right? So this is of type suit, as in the enum, and a private int number. So the card has a suit and a number.
It's from 2011. And you can throw this one around. It doesn't sound well.
All right, and so now we need to create the getter and setter for the suit and the number. And do you remember how to do this?
Yeah, you in the class. Yeah, you make it. You can tell it to make your own getter and setter.
Let's just make it do the work. So source, generate getters and setters, and voila, here it is.
Do I have to click the number in the suit?
You should not have to. You should just put it in the white space.
One generate element count.
So take a look, please, up here. So it will be source. So these methods that we're generating, they're called getters and setters, right? Getters and setters. So that's what you want to click, and it should generate, and you want to select all.
Oh,
And
there
then,
you go. I got it.
great. Well done, Anson.
It's the minimum.
All right, so let's go in the main. And then we're going to instantiate a card object. Card is equal to a new card. And so here's what we're going to do. We're going to use the set method to set the suit to suit dot. And so now we're calling the enum. And when we say suit dot, it's going to show us the drop down of the available constants that belong to the enum. And so you can pick one, say spades. And card dot set number of 1. So then we're setting the card has two. We only need 2 instance variables to describe the card, right? So we set the number and the suit, and this allows us to exercise the enum skill, the new enum skill, and then we're going to call a method to display the card. We pass it the card object, and we haven't called this method yet. We need to create it, so it's going to give you an error until we code it in a moment. So you need to, again, make sure you are outside of the main brackets, curly braces, and then public static void display card. Now get the face cards first. Okay, so if card.get number is equal to 1, system out print ace. Now I'd like you to copy system out print and put it in your clipboard so that we can just paste it instead of typing it over and over, because we're going to be doing this multiple times. Okay, so if the number is 1, then this is going to represent an ace. Else if the number is equal to 11, this will be system out print, and again I'm just pasting it here and replacing it with a jack. You should probably just copy the entire well, in any case. And then card.get number, if it's equal to 12, it's going to be the queen. Would be a king. So we have accounted for the suits. And else if the card.get number is greater than 13, we're just going to print out a question mark because there is no such suit. So a moment to catch up here if necessary. And then we have system out print space of. We're going to say a spade of, or rather a queen of spades, for example. And then the next if then else, excuse me, is going to be to display which suit of the card we have. So we're going to have if card.getSuit is equal to suit.spades if it's equal to suit.hearts else if. But else if environments. Environments. And then we're going to give a system out print line. Okay, so we have a bunch of problems here. What is this all about? Let's see. Everything's in red. Let's see here. So it was a matter of saving all. So that was easy. I'm sorry?
Can you scroll to the very bottom?
Yes, please. Go ahead. And while you are finishing up, I'm going to run the program real quick. And it tells us we have an ace of spades. Isn't there a song like that? All right. So once we have this running, I would like to answer any questions you might have. And then what I would like to do is I would like you to edit this code so that you make the number and the enumeration be, instead of hard-coded, randomly generated. So you generate a random card number and a random enum. And you need to figure out how to do this. Right? So that every time you run the code, instead of printing always ace of spades, which you got from the hard-coded values on line 10 and 11, it's going to randomly generate the number and the enum. And feel free to speak with your neighbor about how to solve this.
Just scroll at the bottom.
Sure. Here. And then if someone has a solution, then you can come and make the change up here. And so we definitely are going to do the Java docs on Monday. It should not take us too long. I think on Monday we'll be caught up. So I'm going to turn off the recording now.
So it's your A